We will now proceed with the next topic, which is now about classes. A class is a data type whose variables are objects. Actually, the purpose of talking about structures a while ago is to give us a view of what objects are, how they are created, and how they are used. So in a while, you will see that structures actually share a lot of similarities with that of actual classes in C++. First, a class must have a definition which includes description of the kinds of values of the member variables, description of the member functions, and a class description is somewhat like a structure definition plus the member variables. Again, when we talk about classes in C++, we actually talk about, for example, instance of a class, or shall we say object, which contains attributes or properties. So these attributes or properties will describe an object. And aside from that, an object or a class also has member functions. For the member functions, or we simply call them methods, these are the things that can be done by a class. For example, let's say we have an object called dog. Of course, a dog can have the following properties or attributes. Let's say a dog can have a name, it can have a breed, it can have a color, and some other attributes which will serve as its member variables. And of course, to serve as its member functions or methods, it should be able to do the following things. So let's say a dog can walk, a dog can bark, a dog can eat, can sleep, and some other things that a dog can do. In the concept of objects, those are what we call its properties and methods, or in this case, member variables and member functions. Here's an example of a class. To create a new type named day of year as a class, we first decide on the values to represent. So for example, this can be a date such as this, using an integer for the number of the month. So let's say a member variable month can be declared with the type integer. Therefore, for January, it should be assigned with a value of 1, February, assigned with a value of 2, and so on. And also, member variable for day should also be declared as integers. Then we can decide on the member functions that we will need to have the following class, which would contain the value for the month and the day. For now, we use just one member function, which we will call output. Now that we have already determined the value or data that will be contained by our class, we will now define the class that we will create. Here's an example of a class definition. As you can see here, this is somewhat quite similar with how we define a structure. In this case, we use the class keyword followed by the class name. And of course, as for the definition, it is also contained in curly braces and of course terminated with a semicolon. Inside our definition, we see the following set of declarations. As you can see here, we've seen a new keyword, public, although we will be talking more of that as we go. Then we have the following. As you can see here, this is a member function declaration. As you can see here, it's still similar with how we declare a function. But this time, this function is declared inside a class. So which means that the function we are declaring is actually a member function or will serve as a method for the class that we declared. And of course, similar to that of a structure, we also declared the following variables, or shall we say member variable, with their respective variable name and data type. After declaring a member function, of course, we also need to define them. So how do we define a member function? Member functions are declared in the class declaration. On the other hand, member function definitions identify the class in which the function is a member, which means in a C++ program, it is possible that we declare and define multiple classes. Therefore, it is important that we must indicate to which class a certain member function belongs. So how do we do that? To do this, we use the following operator. As you can see here, it is used to indicate to which class a member function belongs. As you can see here, this looks similar to how we define a function. But in this case, what we have here is an example of how we define a member function for a class. In this case, the class day of year. Now let's talk about member function definition. As we have seen a while ago, the example that we saw follows the following syntax of how we define a member function. As you can see here, it's still similar with how we define a regular function. In this case, we indicate the return type, and then we indicate the class name to which the function belongs, then using this operator, followed by the function name, and of course, the parameter list should our member function requires the following. Then, inside our function body is of course the C++ statements which would compose our function definition. Here's a specific example. As we have seen a while ago, the operator that we use to refer to the class to which a member function belongs is called the scope resolution operator. It tells the class a member function is a member of, or simply put, it simply tells us to which class a member function belongs. In this case, it indicates that the function output is a member function of the class day of year. The class name that precedes the scope resolution operator is called the type qualifier. So what's the difference between the two? In this case, the scope resolution operator is used with classes to identify a member, in this case to identify a member function. And in the case of the dot operator, it is used with variables to identify a member such as birthday. In this case, birthday is a member variable of the class day of year. Now, how do we call member functions? Calling the day of year member function output is done in this way. For example, we declared the following. of type day of year. For example, we would like to call their respective member function output. To do so, we simply do a function call, but in this case, it's not just a regular function call. We need to use the dot operator to specify which class this particular function belongs to, as we can see here. Note that today and birthday have their own versions of month and day variables for use by the output function, which means they are completely different from each other. Here's an example. Let's say we have the following sample program. So this will show a very simple example of a class. In this case, we have the following. The class declaration. In this case, this is where we specify all its member variables, and also this is where we declare its member function. In this case, we have the member function output. Then we have our main function. And in this case, as you can see here, we declared two instances of the class day of year. If I may add, when we declare instances of a class, we can simply refer to them as objects. So therefore, we declared two objects of type day of year. As you can see here, we tried to access the member function or the member variable of the object today by using the following syntax. As you can see here, we simply use the dot operator to access the member function that we declared a while ago. And we also did the same to another instance of the class day of year, which is birthday. So let's run this example and see how it works. Okay, I forgot. This should be declared as public. Okay, let's try it again. Okay, for example, I'm going to enter April and I'm going to enter 15. I will enter 6. I will enter 12. Okay. Anyway, it's just an example, nothing interesting there. But the point of this program is to demonstrate how we create a class and how we access its member function and member variables. Let's proceed. When we talk about classes, or shall we say object-oriented programming in general, we have the concept called encapsulation. We can simply define encapsulation as the combination of a number of items, such as variables and functions, into a single package, such as an object of a class. That's what we saw a while ago. We combined member functions and a number of member variables and packaged them into a single entity, which we called a class. And whenever we declare instances of those class, we refer to them as objects. Talking about our example a while ago, we have a little problem with the class that we declared. For example, changing how the month is stored in the class day of year requires changes to the program. For example, if we decide to store the month as 3 characters instead of an int, then the following call to this member variable will no longer work. And another one, this if statement will no longer work because of the changes to the input that was provided for this member variable. Also, the member function that we created will no longer work. In this case, the function output will no longer work, which means we need to change our class definitions. Changing the implementation of day of year requires changes to the program that uses day of year. An ideal class definition of day of year could be changed without requiring changes to the program that uses day of year. So that's another advantage of writing classes and properly implementing those classes, which means a well-written class is easier to maintain, and therefore, whenever changes are required to our program, we don't have to change the actual program that uses the class that we made. Instead, we can simply modify our classes, and of course, whatever change that we did will be reflected to the entire program. So how do we fix our class? To fix day of year, we need to add member functions to use when changing or accessing the member variables, which means it is a good practice that we write member functions that are specifically intended to set and retrieve the values of our member variables, as opposed to what we've seen a while ago, in which we directly access our member variables. That is actually not advisable. As you can see here, using the dot operator, we can directly access our member variables. Although that is allowed, but that is actually not a good practice. There's a better way of doing that, and this is one of them, which means we need to write specific functions for changing or accessing our member variables. If the program never directly references the member variables, changing how the variables are stored will not require changing the program. Also, we need to be sure that the program does not ever directly reference the member variables. As I have mentioned, although it is doable, it is possible, but it is not a very good practice in actual programming. So this is where we need to use the following keywords. A while ago, when we ran our program, it generated an error, which means that we can't directly access our member variable without specifying whether it is public or private. In this case, C++ helps us restrict the program from directly referencing member variables. That's what we saw in our previous example. We were not allowed to directly reference our member variable. Therefore, we need to specify that they should be public. Private members of a class can only be referenced within the definitions of member functions. So that's a better way of restricting access to our member variables, which means member variables are not intended to be public. Which means if we need to access our member variables, we need to write specific functions to do so. Therefore, member variables are recommended to be declared private. If the program tries to access a private member, the compiler gives an error message, as we have seen a while ago. Private members can also be variables or functions, which means aside from member variables, we can also declare some of our functions to be private. Now let's talk about private variables. Private variables, as we have mentioned a while ago, cannot be accessed directly by the program. Changing their values requires the use of public member functions of the class. Whether we would like to access or we would like to change the value of a member variable which is declared as private, we need to write a specific function for such purpose. Here's an example. For example, we would like to set the private variables month and day in a new class. Then we can use a member function such as this one. As we can see here, assuming that we declared month and day to be private member variables, therefore, we no longer have the ability to access them directly using the dot operator. Instead, we now need to use the following member function. In this case, we have this setter function, which in this case intends to change or assign new value to our private member variables. The keyword private identifies the members of a class that can be accessed only by member functions of the class. Members that follow the keyword private are private members of the class. On the other hand, the keyword public identifies the members of a class that can be accessed from outside the class. Members that follow the keyword public are set as public members of the class. Therefore, all members of a class which are declared public can be directly accessed using the dot operator, as opposed with private members or private member variables which can only be accessed using member functions. Here's a new version of the class that we have. In this case, our new version has the following changes. It uses all private member variables and uses member functions to do all manipulation of the private member variables. Let's take a look. This time, we have the new version of our class day of year. As you can see here, we have the following member functions. If we will take a look at the following member functions, they are declared as public. And this time, all the member variables are now declared as private, which means they can no longer be accessed directly. And we added another function, which in this case, it is declared as a private function. Usually, member functions that are declared as private are simply considered as helper functions. Now let's take a look at our member functions which were declared as public. As you can see here, we have a function intended to receive input from the user. Then we also have a member function intended to display output to its user. And in this case, we have the following setter function. In this case, this function is used to assign values for our member variables. In this case, we can call this setter function as mutator function. And here's another set of functions that is used to access the value of our member variables. We have the following function, getMonth and getDay. As you can see here, it is used to get the values of our member variables. We can also call such function as mutator function. It's because it is used to change or modify our member variables. So how do we use private variables? It is normal to make all member variables private. Private variables require member functions to perform all changing and retrieving of values. As we have mentioned, accessor functions allow you to obtain the values of member variables. That's what we see with setter functions. Here's an example. On the other hand, we also have what we call mutator functions, which allows us to change the values of member variables.